Hello and welcome to another geometry lesson by eMath Instruction. My name is Kirk Weiler and today we'll be doing Unit 1, Lesson 7 on angle bisectors and perpendicular lines. Now in our original unit in geometry, Unit 1, remember we're trying to build up our base knowledge of geometry and different tools and jargon, vocabulary within geometry. So today we're going to be introducing angle bisectors and perpendicular lines, both of which you've probably heard of before. So let's start with angle bisectors. Now, since angles have degree measures, it makes some sense that an angle could be divided into two congruent angles. That's exactly what angle bisectors are, but let's take a look at the technical definition of what an angle bisector is. An angle bisector is a line or portion of a line, such as a ray or a segment, that divides an angle into two congruent angles or two angles of equal degree measures. All right, so this is simple enough. And we're gonna see the word bisector quite a bit in this course. All right, bi generally means two, and to sect something means to sort of cut it up, all right? So bisecting generally means to cut something up into two equal-sized pieces. Let's take a look at exercise number 1. Given angle EFG, shown below, do the following using a protractor and straight edge. Letter A, find the measure of angle EFG. All right, awesome. Well, pause the video now, grab your protractor, and find the measure of angle EFG. All right, well, let's take a look. Let me bring it down here. I've got to remember, always put the vertex of my angle at the center of my protractor circle. And let's see, I'm trying to get it set there. All right, that looks good. A little bit hard to see on here, but it looks like the measure of angle EFG is 64 degrees. 64 degrees. Now again, if you're getting something slightly different, 62 degrees, 63, 64, 65, something in there, you're probably fine. Okay, it's a little bit tricky, especially given the fact that worksheets can get a little bit warped when they're photocopied and whatnot. All right, let's take a look at letter B. Using a protractor, locate a point H so that when ray FH is drawn, it bisects angle EFG. Draw in ray FH. Okay, so somehow, right, I've got to use my protractor to figure out some place where I can put a point H, and point H can go in a variety of locations, okay? But when I draw in the ray that starts at F and goes through H, it's got to bisect that angle. It's got to cut it in half. So pause the video and see if you can locate a point H that will do that job. All right, well, the key obviously is going to be what is half of 64? Okay, so I'm just gonna write this down, right? 1/2 times 64, or 64 divided by 2, is 32 degrees. So if I bring my protractor over, again, put the center right at F, and I find, or I do the best job I can of finding 32 degrees, right about there, okay, I can then draw a ray that goes through that, and I can actually locate point H anywhere I want on this ray. I'll put it where I made that mark just to make the mark not look so bad. All right. And probably visually right away, you can probably tell that that angle and that angle are congruent, are of equal measure. Now, letter C. Name the two congruent angles and state their common measure. All right, so what congruent angles do I have? Write those down, and maybe even write them down with a congruent symbol in between them. All right, and then tell me what each one of their measures are. Okay, well, the two angles are angle EFH, and that's got to be now congruent to angle GFH. What are their two measures? Well, we already know that the measure of EFH is 32 degrees, right? And I could then rotate my protractor like this, and I can also see that the measure of angle EFH is equal to 32 degrees. So their common measure is 32 degrees. Real simple idea, right? An angle bisector cuts an angle in half. It's just the easiest thing in earth. And eventually we'll see segment bisectors, and not surprisingly, segment bisectors will cut a segment in half. Now, the one thing that I've noticed before with students and angle bisectors is that sometimes people think that what an angle bisector does is somehow makes it so that this ray is equal to that ray. Well, a couple things. Rays can't be equal to each other. All rays are infinitely long, and all rays are congruent to one another. So what we're doing when we have an angle bisector has nothing to do with this ray nor that ray. It has to do with the angle that's created from this ray to the angle bisector, and the angle then from this ray to the angle bisector. And those two angles have to be congruent. In this case, they both have a measure of 32 degrees. All right, let's keep going and working with this. Angle bisector fact. For a given angle, there exists only one line that bisects the angle. Another way of saying this is that for any angle, the bisecting line is unique. Okay, and this probably makes sense, right? There is only one line that kind of goes right down the middle of any given angle. Okay, there's only one that does that. All right, and that will have consequences later on in the course. Let's take a look at exercise number 2. In the diagram shown below, points P, Q, and R are collinear, and ray QS bisects angle PQT. Letter A. Based on the information given, which two angles must be congruent in this diagram? Awesome. Well, make sure to read through everything that you're told here, and then here, write down two angles that must be congruent based on what you're told. All right, well, we're told that QS bisects angle PQT, right here. QS bisects angle PQT. Well, angle PQT is right here, right? And QS is right here. So the two angles that are created that are equal are these two angles. That third angle has really nothing to do with it. So we can say that angle PQS is congruent to angle TQS. All right. Now, letter B. If the measure of angle SQT is 72 degrees, then what is the measure of angle RQT? All right. Play around with this a little bit. Pause the video now and see what you can do. All right. Well, up here, I called it angle TQS, but angle SQT and TQS are the same angle. So let's do some labeling on our diagram. Angle SQT is 72 degrees. Well, we know that angle PQS is also 72 degrees, and then this angle is the one that we're looking for. So, how do we find it? Well, we know that points P, Q, and R are collinear. And what that tells us is that PQR as an angle is a 180 degree angle, right? It's a straight angle. And that means, right, the measure of angle PQS plus the measure of angle SQT plus the measure of angle RQT, which is the one that I really want, is 180 degrees. All right, that we know. This plus this plus this is 180, but each of these two are 72 degrees. All right, so it's simple enough, right? I add these together, that's 144 degrees, and that means the measure of angle RQT is going to be 180 minus 144, and that's going to be 36 degrees. And that's it, right? This is what I would call a fill in the angle problem, right? Using things that you know to fill in a variety of angles on the diagram. Okay, let's keep going. Exercise number 3. In the diagram below, Angle ABC is a straight angle, i.e., points A, B, and C are collinear. Letter A. Using a protractor and straight edge, draw a line that bisects angle ABC. Okay, well, pause the video now and think about this a little bit. I want to bisect angle ABC. Pause the video now and see what you can do. Well, the measure of angle ABC is 180 degrees, right? And bisectors cut an angle in half, right? 1/2 of 180 degrees is 90 degrees. So I have to draw a line, well, that cuts that, 180 degree angle into two 90 degree angles. So I'll find that 90 degree angle right here. I can now hopefully move this out of the way or resize it so it's huge and scary. I can now bring my straight edge in, and I will draw that line in, right? And that definitely then creates a 90 degree angle here and a 90 degree angle here, right? It bisected that 180 degree angle. All right, letter B. Once this line is drawn, 4 angles are formed. What is the measure of each angle? Well, there are 4 angles formed, right? 1, 2, and then 3, 4. Now we know that's 90 and we know that's 90. Now these two angles, right, are vertical angles, and we know vertical angles are equal, so that's 90. And the same thing can be said here, that's 90. So they're all 90 degree angles. All right, and finally, letter C. What type of angle is each of the 4 angles created? So what are all these 4 angles called? Well, we have a name for 90 degree angles, and those are right angles. All right, so all 4 are right angles. All right, and that leads us to our next very important idea, which is perpendicularity. Let's talk a lot about what perpendicular lines are. 2 lines or part of lines, such as segments and rays, that intersect to form only right angles are called perpendicular. We use the symbol, perpendicular symbol, to indicate perpendicularity, such as line AC is perpendicular to line BD. Now, of course, when you look at this particular symbol, right, and let me draw it just a little bit bigger up here, right, it looks like sort of, an upside down capital T, okay? And it certainly looks like 2 lines, or 2 line segments, sorry, that are perpendicular to one another. Now, I worry a little bit because sometimes people see this symbol and they think bisecting, maybe this line is cutting that line in half, something like that. But we need to know the symbolism of geometry, and that will mean 90 degree angles are formed. So let's take a look at exercise 4. In the diagram shown, we are given, parentheses told, that ray HI is perpendicular to ray HL. Measure of angle IHJ is equal to 20 degrees, and ray HK bisects angle JHL. Determine the measure of angle JHK. Explain how you arrived at your solution. Fantastic. Okay, what I'd like you to do is pause the video right now, play around with this problem, and see if you can figure out what the measure of angle JHK is. Pause the video now. All right, well, let's kind of distill it all down. What do we know? Well, the first thing that we know is HI is perpendicular to HL. And that tells me, right, using my right angle symbol, that that entire angle is equal to 90 degrees. All right, that's one thing I know. Now, another thing I know is that the measure of angle HIJ is 20 degrees. I got to be able to figure out which angle that is, but it's right in here, right, 20 degrees. Finally, I'm told that HK bisects JHL. All right, so HK, let me do this in red, which is right here. HK bisects JHL. And that tells me that this angle and this angle are congruent to one another. Okay, so which angle do I want to know the measure of? That's JHK, that's this guy. Okay, so how do I figure it out? Well, I can take my 90 and I can subtract 20 degrees. Oh my, what is that? Minus 20 degrees, and that gives me 70 degrees. And that, right, is the measure of angle JHL, right? That's not my answer, that's just JHL. But I know that HK bisects angle JHL, so it cuts it in half, which then tells me the measure of angle JHK must equal 1/2 of 70 degrees, which is equal to 35 degrees. And that's it, right? Simple enough. Let's take a look at one last issue. Perpendicular segments, in other words, 90-degree angles, arise in many of the most common geometric figures, such as right triangles, rectangles, and squares. So right angles are going to come up a lot in our business of geometry over the span of the year, right? And right angles are always created by perpendicular line segments, or perpendicular rays. Let's take a look at exercise 5. A rectangle is defined as a quadrilateral with 4 right angles. Rectangle EFGH with diagonal HF is drawn. State all pairs of perpendicular sides make formal statements. All right, great. So what I'd like you to do is write down, statements. Let's actually start with one together. So I know that this is a right angle. So I can say that segment EF is perpendicular to segment FG. Now, if you're wondering, and I feel like I should emphasize this again and again, it doesn't matter whether I call this EF or FE. It doesn't matter whether I call this FG or GF. They're the same segment. So EF is perpendicular to FG. Go ahead and write down 3 additional statements about perpendicularity. All right, well, I'm going to just kind of go around the rectangle. I can now say that FG is perpendicular to GH. All right, I can say that GH is perpendicular to HE. And then finally, I can say that HE is perpendicular to EF. And right, notice for every 90-degree angle, for every right angle, there's a perpendicularity statement. Okay, let's take a look at letter B. Just leave it like that. If the ratio of the measure of GFH to the measure of EFH is equal to 3:2, then find the measure of angle GFH. All right. We're going to have a lot of ratio work in this course. And a lot of times those ratios are going to be presented kind of like this. And almost always when you have a situation like this, you want to do the following. I'm going to let the measure of angle GFH be equal to 3 times x. And I'm going to let the measure of angle EFH be equal to 2 times x. Now, I don't know what x is. X could be 22, it could be 95, I'm not sure what it is. But as long as GFH is 3x and EFH is 2x, then the ratio of GFH to EFH will be 3:2. It doesn't matter what x is, all right? Now, let's take a look. We want to find the measure of GFH. Let's kind of label these on the picture. GFH is 3x. EFH is 2x. Okay, We want to solve for x because that will then allow us to figure out the measure of these two angles, or better yet, just the measure of GFH, because that's the only one they asked for. Well, clearly, the sum of this angle and the sum of this angle must be 90 degrees because they form a right angle. So I can now say 2x plus 3x is equal to 90. That gives me 5x is equal to 90. Divide both sides by 5. All right, what do we get? 1, 4, 90. I want to make sure I get this right. I would hate to botch this. There we go. Yep. I just wanted to make sure. X is equal to 18. All right. Now, that is not what the measure of angle GFH is, right? That's just what x is. To figure out the measure of angle GFH, what I want to do is now take x and substitute it into this. So, the measure of angle GFH is going to be 3 times 18, which is 30 plus 24, which is 54 degrees. I could easily check to see if I'm right by then taking the 18, plugging it in here. 2 times 18 is 36. 36 plus 54 is 90. Boom. I know I got it right. But they didn't ask for EFH, so I don't have to do that. All right, let's summarize. So today we saw two important things that almost seem like they're not connected. One of them is an angle bisector, right? This idea that I can take any angle out there and I can cut it in half with a line, right? A unique line, right? That divides that angle into two angles that have the same measure, two congruent angles. The key is I can also do that with a 180 degree angle. And when I bisect a 180 degree angle, I get two 90 degree angles. And in fact, if I bisect a line, a straight angle, with another line, then I get four 90 degree angles and I get two lines that are perpendicular to one another, right? So perpendicularity is all about 90 degree angles being created, and angle bisectors is all about taking a line and cutting an angle in half. We're going to see both of these ideas time and time again in geometry. For now, I just want to thank you for joining me for another geometry lesson by eMath Instruction. My name is Kirk Weiler, and until I see you again, keep thinking and keep solving problems.